Hi, I am Arup Biswas from the Institute of Mathematical Sciences, Chennai, and I shall be talking about benefits of starting again. Let me first introduce you to different kinds of search processes we see in nature. For example, a predator is searching for prey or face recognition in a crowd, or a research student is searching for a new problem. From a scientist point of view, finding the global maxima or minima in a complex potential landscape, or how enzyme finds a particular substrate, or finding an effective algorithm to find the optimal solution are some interesting search problems. So natural question then arises how to search efficiently in less time. To delve further, take the example of animal searching for food near its home. It does not know a priori where the food is, so it starts searching randomly around its home. Some days it will be lucky enough to find the food very soon, but there will be days when it can go in a completely opposite direction from where the food should be, and it can get completely lost in the jungle. Now compare this to the scenario when the animal does not search indefinitely but decides to return home after searching a while, take some rest, and again start the search for the next day. The process continues until the animal finds the food. This has the advantage that the animal cannot get lost now. But if the animal decides to return home too frequently, then also it does not give himself enough time to even get close to the food. So too much of restart is again bad. If we plot the search time to the frequency of return, thus we see for very low and high frequency of return, the search time is very high. But there is some intermediate value of the return frequency for which the search time is optimal, and this can be proven mathematically also. Apart from its search benefits, restart renders interesting statistical properties in a system too. For example, take the random walker which moves up or down depending if the coin gives head or tail. The position of the walker at any time is random, so we ask the probability of finding the walker at a position x, and the distribution comes out to be universal Gaussian form and which is ever evolving with respect to time. Now take the same system where the walker intermittently decides to return to the origin and start doing the random walk again. In that case, the distribution is of highly non-Gaussian form, and restart stabilizes the distribution so that it does not evolve with respect to time. We recently studied the enzymatic reaction where the enzyme and substrate compound intermittently unbinds and goes back to the initial components, and the reaction is restarted. By doing so, we see that the product formation time, which we plot in the y-axis, is lowest when there is some certain or finite unbinding rate, and the same plot we obtained earlier. I shall conclude by recapping the grandfather's advice, that is start again, this time you may be successful. Thank you.